Hello! Data structure in Java. Pictorial representation of dynamic memory allocation. Now pictures are something good to look at, right? So coming up. Now look at the structure. Here I have got this one I have kept ready for you to look at. And this one says H9 is an internal value because whenever you save something, whenever you want the memory space from the compiler, then this internal address of the memory surfaces. It is given, it is allocated. Now this H9 is therefore an hexadecimal value of the memory cell number. This one is generated from the compiler side as an internal value. Now this H9 therefore tells me the location in the memory where my data is being stored. This data is that data part and this is the address part. Now if I want to store the next one, you see there is space crunch beside it. It cannot be saved beside it. So what the compiler does is this time it creates the next block here in my program. I am creating a new address for the similar data type. Now this one will therefore have to be given a memory allocated space, reserved space. Assume that space is P4. Okay, this is just allocated internal value given by the compiler. Now this one's address part. Address part therefore begins with null. Okay, in the very beginning, let us say that the address in the very beginning is null. Okay, and then I put the data that I want to be saved. Then I put the data here in the data part, okay? And then I have to connect these two. So what I do is here in the address part, over null, I fill in the address of the previous allocated address. That means this H9. Now let me show how will I put H9 over here. This H9 has to be given to me by somebody, and there I will put the H9. Now I'll have to name this. As you know, I can name the first node as it was told there as start. I'll come to the program very soon, but assume that the first one is named start. Start is a node whose value begins with H9, and then here I name this one, call it move, or some other names can be given like 2 1. Some names are there that can be given, front, rear, like all. Now this move therefore is another node. The node move has got two data. One is the data part and the other will help me to know where is the second data. So I have got two data here, 48 and 67. The first data is present under move, and from move I can know the address of where is the next. Okay, now with this comes up the situation of how can I locate all my internal data addresses. Now with this comes a small story that I would love to tell you right now, since we are seeing the pictorial image. This pictorial brings me to a picture brings me to movies. Do you love watching movies? And that also in movie hall, that is a cinema hall. If you can picturize, if you don't like movies, then please write in the message box and then I will think of one more example. But if you like watching movies, then here comes a very beautiful pictorial imaginary situation. You know, it had happened sometimes. It can happen. Says there's a group of friends who are going to watch a movie, but they did not get continuous tickets. But the movie hall inside it is dark. But you know, you can trace out the seat numbers. Now just make a guess. The seat number is an internal value or it is an external value, like the name of your friend. Is the name of your friend an internal value or an external value? Right. So I'm telling the answer because this is a one-way video. The seat numbers are going to be internal values and the names of the friends are going to be external values. If you want to go inside the hall and call someone by name, you may get 4 or 5 people responding. But if you can trace the seat number, then it will become a unique value. Right. Now here it is something like one friend is coming, is given a seat, is getting allocated to a seat, right? And what is happening after that is that seat in that seat wherever the friend is getting allocated, the friend is keeping a track of where is the next friend. Now, in this way, there can be a chain like, chain. You can keep on imagining more and more friends or, group of people are going on joining, and the chain is getting is filling the memory with wherever there is space, it is getting allocated there. Now you look at it, all these places are giving me the effect of a continuous data sequence. Right. Now this will be explained in the program in the coming video. Okay.